Hello students, in this video we are going to discuss the compound microscope. The compound microscope is used to get more magnified image as compared to a simple microscope what we have discussed in the previous class. Object placed in front of the objective lens and the image is seen through the eyepiece. The aperture of the objective lens is less compared to the eyepiece because object is very near, so collection of more light is not required. Generally, object is placed between f and 2f. Due to this, a real inverted and magnified image is formed between 2f and infinity. It is known as intermediate image A dash and B dash. The intermediate image acts as an object for the eyepiece. Now the distance between both the lenses are adjusted in such a way that the intermediate image falls between the optic center E and the focus Fe. In this condition, the final image is virtual, inverted and magnified. See here, the object AB is taken between F0 and infinity. One ray is parallel to principal axis, pass through F0 and one more ray is passing through the optic center, travels without any deviation. These two are intersecting here, so the image formation A dash B dash. This A dash B dash acts as the object for the eyepiece, and we are adjusting the gap between the objective lens and eyepiece such a way that this A dash B dash lies between Fe and optic center of the eyepiece. Now if you represent the distance of the object from the objective is U0 and the final image the image formed by the objective is V0, and focal length of the eyepiece is Fe. This A dash B dash is at distance of UE from eyepiece, and the final image formed. Actually here these rays which are refracted in eyepiece will travel such a way that actually these are diverging rays. They appears to diverge from a point. This is nothing but the final image A double dash and B double dash. Here the condition we are taking, the final image is formed at the least distance of distinct vision. Now come to magnifying power of this compound microscope. From the definition, the magnifying power of compound microscope is equal to beta by alpha, where beta is the visual angle with instrument and alpha is the maximum visual angle for unaided eye. We can prove that this is equal to linear magnification of objective lens or objective piece multiplied with angular magnification of eye lens. So we can write m naught into me. M naught is nothing but v naught by u naught, and this me in the previous simple microscope we have seen d by u. So here we are writing d by ue. So eyepiece acting as like simple microscope here. That's why we are taking d by ue. We can write two conditions. The condition 1 or case 1. When the final image is formed at D, that is but least distance of distinct vision, then magnifying power is equal to V naught by U naught, and this D by UE can be written as 1 plus D by FE. This is proved in simple microscope, which one is already discussed. If you have any doubt, you can once visualize that video. That is also can be written as V naught by U naught can be written in terms of focal length of the objective F naught by F naught plus U naught into 1 plus D by FE. It is another form. And in terms of V naught, if you are writing F naught minus V naught divided by F naught into 1 plus D by FE. That is also can be written as height of the image divided by height of the object into 1 plus D by FE. Here height of the image, so this is intermediate image height, not the final image height. Why means this HI by H naught is corresponding to objective lens. While coming to the second case, when the final image is formed infinity, we have the magnifying power is equal to V naught divided by U naught, and D by UE is nothing but D by FE. We got it. The same expression we can write F naught by F naught plus U naught into D by FE. That is also is equal to F naught minus V naught divided by F naught into D by FE. that is also is equal to height of the image, that is intermediate image, divided by height of the object into d by fe. Any form you can write it. Based on the requirement, we can write. Here, if you come to the tube length, so there is a length of the tube L can be taken as V naught plus UE mod. This is for the first case, and for the second case, same tube length can be is equal to V naught plus FE, and we can use the sign convention while we are solving the numericals. U naught should be taken as negative and V naught will be taken as positive. F naught is equal to positive value. UE will be negative. VE will be negative. FE will be positive. Magnification of the objective will be negative, and magnification of eyepiece will be positive. Overall, complete angular magnification will be negative for the compound microscope. So this is the different cases, different sign conventions, different formulae for magnifying power of a compound microscope. Thank you.